Welcome back. In this lesson, we're starting 5-3, solving polynomial equations. So we've done a lot of things with polynomials so far. We've talked about how to name them, how to find their maxims and mins, describe their end behavior, all that fun stuff. Now, this section is all about solving them, getting those answers where they cross the x-axis, the roots, solutions, zeros, however you want to talk about it. That is our focus today. In this section, we're going to ultimately learn 4 factoring methods. So yes, factoring is back and in full force. So we're going to spend 4 days talking about the different factoring methods for higher order polynomials, because you know how to factor quadratics. But now we're going to talk about how do we factor higher degree polynomials. So today's method is when you can factor out a GCF from a cubic and then factor the remaining quadratic normally. So this you actually already saw in chapter 4. We did slightly touch on this, where if there's an x in every single term, so here notice, every single term has an x. That means I can pull that x out. And what that's going to do is going to drop the degree of each monomial piece by 1. So by taking an x out, the x cubed drops to x squared, the x squared drops to x, and the x just drops out completely. Once you've done that, now you have a quadratic left. A quadratic that you are going to be able to factor. 2 things that multiply to 21, add to 22. Well, we're going to be talking about 21 and 1. Once you get to this piece, now you simply solve each independent one. Now this is where we get to use a zero product property. So that is indicating an x of 0. That's indicating an x of negative 21. And that's indicating an x of negative 1. So again, this first day of all this factoring stuff is literally what we did back in chapter 4. Okay? I just want to make sure you take a day, get really good at it, because there's going to be a lot more factoring that we're going to do later on. This next one, notice, again, I have x's in every single term. So what I'm going to do is I'm going to pull an x out. That's going to decrease the degree of each of those monomials by 1. Once I've taken that out, now I can factor that remaining quadratic. So 2 things that multiply to negative 18 and add to negative 3. I'm looking for a negative number and a positive number. And that combination should do the trick. Negative 6 times 3 is negative 18. Negative 6 plus 3 is negative 3. And of course, once I do that, now I use the zero product property. So remember that x is sitting out front by itself, just means an x of 0. That represents an x of 6. And that represents an x of negative 3. Alright, now sometimes you'll come across problems where more than just an x can come out. So notice in this one, every term does have an x again. So we know we're going to be pulling that out. But I also want you to notice that each term is divisible by 2. So remember, this one, I can actually pull out a 2x. So 2 divided by 2 is just 1. Then the degree drops. 28 divided by 2 is 14, and the degree drops. And then 90 divided by 2 is 45, and the degree drops. And I'm left with that. And now that I have that, now I can factor that like I always would. Remember this positive right here, and the negative with the 14, that's telling me I need 2 negative numbers. So 2 negative numbers that multiply to 45, add to negative 14. Well, we're going to be talking about 5 and 9. And once you get to that point, now I'm going to take each piece and set it equal to 0. So here 2x, well if 2x is 0, that means x has to be 0 still. Even if there's a number out there with it, the x piece still has to be 0. Here we get x of 5 and x of 9. Those are our 3 solutions. So this next one, every piece has an x, so I know what x is coming out. Now here, be careful. Even though you see a 2 with the 2x cubed, notice not every term is divisible by 2, so don't get too hasty about that. Okay? In this one, you can actually only pull out the x still. So don't get too excited about pulling a bunch of stuff out. Only pull out what you actually can. In this case, you can only pull out an x. Now, what that does mean, however, is this is going to be one of our more difficult factoring ones. Because this is one of those cases where a does not equal 1. So I know I need a 2x and an x in there to get 2x squared. To get 10, that means I need a 1 and a 10, or a 2 and a 5. And what that also means is they need to combine, those interconnections need to get me a negative 1, because that is a negative 1x. So, I'm going to do this combination, okay? Now, again, I'm not going to spend that much time on factoring because we have already spent a lot of time working on factoring. What I want to spend my time on is reminding you how to check you've done it right. Right? For these more complex ones, check those interconnections. Negative 5x and 4x. Does that add up to the negative 1x? And yes, it does. So, remember when you're factoring, always take a moment, check those interconnections to make sure that you've actually factored it correctly, please. Now that you've done that, now I solve. So this gives me an x of 0. This is one of those more complex ones. So recall, I would like to see your work for the more complex ones. I actually set that equal to 0. Add the 5 over and divide by 2. And then there, you get x of negative 2. Alright, so lots of good stuff still happening in the world of factoring. But again, the key is you've already seen this, so hopefully this isn't really new or too complicated for you. So, of course, just like before, whenever we did factoring, we remembered how to equal 0. Well, that still holds true with this. So if I give you something and it doesn't equal 0 and I'm telling you to factor it, it means you better move that over. So subtract over the 63x. Now you're ready to factor. Every single term has that x, so I'm going to take out the x to route the degree of every monomial piece. And now I can factor as normal. So this is our nice case. So negative 63. All right, well, negative 63, I'm going to break that up into 7 and 9. A positive 9 and a negative 7. So those will multiply to a negative 63, and they will add to a positive 2. And then I go through every piece and identify what 0 the factor will give me. And last, but certainly not least, oh, actually not ready for that yet, because it's not set equal to 0. I need to add that 35x over. Now once I've done that, now I have everything on one side and it equals 0. Now I know x is in everything, so I pull that x out. And I'm ready to factor that quadratic that's left. So multiplies to 35, adds to negative 12. What that's telling me is I'm looking for two negative numbers, because that positive is telling me I'm looking for numbers of the same sign. The negative tells me that those two numbers are going to be negative. So negative 5 and negative 7. Then take each piece and tell me what 0 it came from. Alright. So, lots of good stuff here. Again, mainly review to give you a nice transition back into factoring. But I do want you to still take time, write that summary for me, okay? Whether it be reminding yourself how you did it back in chapter 4, how it connects with where we're going here, just whatever you feel like will help you, okay? Just write me that summary, then come back ready to work on your practice work.